Hello, Advanced Chem. This is day 7 of e-learning. Hope everything's going great. Again, so far, we're almost there. Okay, I think after this day, there's about 3 more mandatory days of e-learning, and then there is about a week of getting caught up. So for a bunch of you, that means just getting your work turned in. At the end of the video, I'm going to talk about I did this before, the grading expectations and just in general, what's expected of you for the rest of the e-learning time. Okay. I think this is our last day of acids and bases. If you're not sick of them yet, this is our last day of it, most likely. Next day or next lesson, so day 8, you'll be looking at rates of reactions, so what affects how quickly or slowly a reaction takes place. And then that'll be kind of almost the end of Chem for, I guess, this semester. After a couple, after day 8, you have 9 and 10, then you're done, for the most part. So, our last day, now I'm extremely upset that we can't do this in the actual lab. Normally this would take about a week, but it is way too complicated to just talk about online. It's unfortunate that it has to be that way. Normally in class we take 1 or 2 days to do a demonstration, and then actually I'll talk about some of the math, and then you take about the rest of the week or 3 days to do an actual experiment on something called titrations. One of my favorite parts of chemistry are actually titrations, acid-base titrations. The whole point of a titration, now again, for today, you'd be reading an article and watching a video of Mr. Bartlett doing some titration work, kind of explaining what a titration is. But about a month or so ago, we did some labs where we found out the concentration of something. So pretty much you made Kool-Aid, okay? And you found the concentration of Kool-Aid by figuring out the moles of Kool-Aid powder, dividing it by the volume of the solution in liters. You found the concentration. Okay, there you go, exciting. But in a chemical sense, how do you know that that concentration is what it is? You did the math and you measured the masses, but there's a lot of errors that could have occurred. So in the science world, in the chemistry world, biology world, in general, just science world, a titration is basically it is a method of determining the concentration of a solution. Okay? It is not as easy as just taking the moles divided by the liters, because in the lab, whenever you make a solution, you're not entirely sure if that's the real concentration. One of the ways to be sure is to do a titration. Titrations are actually extremely useful. Again, when you watch Mr. Bartlett's video, you'll see what's actually going on. There is some math involved, but for us this year, we're not going to deal with the math. I just wanted us to get the concepts down. You need something called the burette. It's this really long, thin glass tube, and you'll see a picture of it on a document you look at and finish today. But the whole point of a titration is to figure out how concentrated something is, how much of something is in a solution. So let's say I have some water, it's just tap water. If you just taste tap water, it tastes a little chloride-y, a little salty kind of. There is chloride in tap water. It's actually useful. There are other salts and other ions in tap water. It's not just pure H2O. That has a very strange taste. You can taste distilled water. Go to the store. No, don't go to the store now. But if you have distilled water at home, try a little bit of it. It's not going to hurt you. It's going to hurt you if you drink. That's all you drink is, distilled water. But anyway, there is some chloride in tap water. And so what you can do as a scientist to figure out how much chloride, you can't just drink it and go, oh, there's about this much chloride. No, you can't do that. You have to actually do what's called a titration. And you get a perfect indication of how much chloride is in tap water. Now again, you don't test all this water. What scientists do is they test they test this a small amount, and then they do another trial, a small amount, and then they do another trial, a small amount, and they do another trial, a small amount. You get the idea. All right, scientists do a ton of trials with the same substance, with the same solution, and they find an average. Okay, and once they do enough trials, once they get once all the data seems good, and they figure out, okay, this must be the chloride content in tap water, they see if that's good or if that's bad. And you can do that with a bunch of things. And again, in the document that you read and look at today, you'll see what titrations are actually used for. Usually, scientists use pH meters or they use color indicators to tell you when a titration is done, etc. So for today, you're going to be reading an article on cheese. I love cheese. It's one of my favorite things to eat. Think if I'm in the mood, I'll look up. There's a YouTube video of like people globbing cheese over everything. It's delicious. I know we've talked in class before about cheese and stuff, but you're gonna be reading an article. It's like 3 pages long, just about cheese and pH and how to make different cheeses. Then finishing up a document. There's also a quiz to take. It's going to be a pH calculations quiz. So you need your calculator, probably a piece of scratch paper to do some work on, but it is, again, on the Chromebook. It's just that Google Forms quiz, like the ones we did before. There's also an acid reactions re-quiz. So if you took the acid reactions quiz and got below a 60%, it actually is an incomplete. Okay? I know it seems unfair, but I can't give you anything under a 60% in the grade book. Okay, if I do, it's not allowed, so I got to give you an incomplete. So the only way to get the incomplete to an actual grade is to get above a 60%. So you need to get over a 60% to have me put the grade in. So for the acid reactions re-quiz, it's just again on the day 7 e-learning page, take that. But what I'm seeing is that I've gotten a couple emails from students saying that it's a lot of work that we're doing. Just keep in mind, all of our stuff is just, we're doing 1 day of chemistry every 3 class days. And that's supposed to be 90 minutes. Okay, it's supposed to be an hour and a half. And our class starts, it should start at 9:15. So at 9:15, that's the expectation that you get to haiku, you look at the B day, you look at the e-learning day, you watch my update video or whatever it says for the agenda. That's at 9:15. If you're not doing that, if you're doing it the day before, that's fine. If you're not doing it at all, then you're saying that there's too much stuff to do and there's too much new stuff to learn. But I'm not getting emails from some people. I'm getting just homework that's submitted without work, even though it blatantly says in bold and highlighter, show work. So that confuses me. It hurts my brain. I'm also just not getting submissions in general. So, I mean, heck, if you want to retake chemistry, just don't submit anything. And then you get to retake it next year. And you wasted a semester. So, your choice, but I would prefer you not do that. Doesn't make any sense. For today, there's that quiz. There's that article to read. The article takes 15 minutes. And then there are some videos to watch and a document to submit. And that should all take under an hour and a half. And all the answers on the document can be looked at, can be found on the article. And if you can't find some, just email me.